Welcome to Let's Make a Game Platformer, episode 4. In last episode we created a simple platform specifying a couple of blocks in the code itself. Today we will extract this information about where the block is and how does it look to some JSON files so that they can be easily modified without modifying the code itself. Okay, so we'll start off with creating a component. So let's create here a package level and create a block component which defines how the block is going to look like. When I use my own entity system, components are actually interfaces. And we will be using here a block component that extends a component. So these block components and their data are based on their names, the fields in the components. So we'll create a couple of ones here. So first of all, it's going to be a get shape, which defines the shape of the block, which is the name of the actual shape asset, so in this case a cube or whatever else we choose to have there. And we also need to have a map of string to string, get textures for paths. Okay, these don't have to be public. We can delete this quickly. Okay, so we have a component here. Now let's create some prefabs. So for this we'll create a new folder in the assets. We call it prefabs. And in here we'll create a, for example, prefab. You will say that it's actually a JSON. I don't know if there's a direct support here for that. Yes, there is. So we will create a dirt. So we will say that it has a block component. And it has two fields, shape, we're gonna finish and fill out in a moment, and textures for parts. Textures for parts. Yeah. Okay. So I'll put some link on the description to what the JSON file is and what the format. As for my own entity system, the way it works is just this, the whole file, the prefab, defines a description of an entity. An entity, as you know, can have multiple components. So each entry here on the top root level of the entity defines a component. This is the component name. It has to match this name. And each field is specified. So each field here you have shape, textures for parts. It has to match the name here, and the value is going to be cube. And this is going to be a map, as you can see, of string to string. So we'll have all and block tiles /dirt.png. So this basically maps to the map specified here. So this is the map. So you can do here a top, bottom, sides as well. So let's maybe just create a grass one as well. So let's copy it. Grass. Also uses a cube and it has, as in here, we have top, which is a block tiles grass. Another one it has is bottom, which has block tiles dirt PNG, and it has sides block tiles grass side PNG. Okay, so we have two prefabs for two different blocks. Let's create quickly a third one. It's going to be the same as dirt, but it's going to be a stone. And it's going to have a stone PNG used here. Awesome. Now we have to create a system that will create a texture atlas with all those atlases, with all those textures that are used in all our possible blocks. So let's create here a block texture mapper. Block texture atlas creator. And it has to be a system. And we want to, no, we don't want to implement anything. We want to texture, add inject, sorry, inject texture atlas registry, and implements live cycle system because we want to be notified. We will have an initialize method, which will basically, no, sorry, we have to do it in post initialize. Oh no, initialize I think is fine. So we want to also have access to prefab manager. So that's how we can read prefabs, and in prefab manager we'll say find all prefabs that have a block component. We want to iterate over them, and to have better access to the data inside of them, we will pass entity manager. So entity manager allows us to wrap entity data, I believe. Yeah, that's the method we want to use. So now we have the data that is just raw data from the file. We will have it in a sort of an entity form. This is really only entity, it doesn't really exist in the system. It's just a sort of a stub for us to play with. And we want to get the block component. And from the block component, get texture and paths, values, texture name, and after we get through all of them, we want to call the texture atlas registry. What was the name that we are using? It was used platforms. That's as good a name as any other for the time being, at least. And we have to have a collection, so let's make a set because we don't want to have duplicates. Texture names, add texture name, and in here we will register all the texture. So let's go quickly through this code. So we will ask for all the prefabs that are available anywhere in the system that have a block component on them. We iterate through them, and we get all the texture for each of one of them. We get all the textures that it uses. So in this case, it's going to be dirt, grass side, and so on and so forth. And we add it to this set quickly and ask the texture atlas registry to make sure that this texture atlas, called platforms, has these textures loaded. So let's see if that actually wrote. As you can see, Our current texture atlas does not contain stone, but when we run it again, this whole program, we should see that this PNG now also contains stone texture. Okay, we have to have a prefab manager. We don't have it in our system yet, so let's include it. Let's see if it starts now, or is there anything else we have to include in our game from the gaming module. Everything's fine, still displays. And now let's take a look at this one, and we can see now that the stone texture indeed was included. So in here we now know that most definitely all the textures that are for blocks gonna be included automatically. So if you add a new prefab here for a different block with different textures, they will be loaded and texture atlas will be created for it. Okay, so now we have some definitions of blocks that we can available, but let's make something go a step further and create a level component. It's going to be an interface, once again, as all components are interfaces in my entity system, and it extends component. That's an important thing. Okay, and we will have here so this level component has to contain all the information about the level. So one of the things that we will have there is has to define where are all the blocks. The way we'll do it is block coordinates. The way we will do this is by an example. We'll create a levels and a new file level sample.prefab. We'll create a prefab which will contain our data, and in there we'll have level component, and this is how we're gonna create the coordinates. Block coordinates. We'll say that so let's take a look at our stuff here. We had add 0 minus to 0, 1 minus to 0. So the way we will do this is by comma separated list of coordinates saying which block we want to use. We want to use grass here. At 1 minus to 0, we want to have a grass as well. At 2 minus to 0, we want to have a grass block. And at, let's say, something to the left maybe, minus 2 at level 0, 0, we'll have a stone. So these names correspond to the prefabs here. So dirt, grass, stone. And here we'll have minus 3, 0, 0, also stone. So we should see two platforms, one grass platform at the bottom right, and like left in the middle a stone platform of 2 blocks. So this is the y coordinates and x coordinates and z coordinates. So now we have to write a system that will basically load this entity, allow us to load an entity and go with it. So let's do it here, level system. You want to register it. We'll create a level loader interface, which will have one method at the moment. Load level name, level prefab name. and level system will implement that method, that interface, level loader. So we have to share two other classes in the context, this interface, and okay, we will implement this method. We will need for this, because we want to create something, we want to have something that will, so this system will create an entity in the environment of the game that will contain the level information. So for this we need entity manager to create the entity, and we need a prefab manager to extract the to load the prefab. So prefab manager, get prefab by name, level data, and entity manager create entity with the level data. So now we have this. So now our terrain, rather than hard coding this stuff here, will instead entity manager will find an entity with a level component in it. This is like a shortcut for getting a first one. Level entity. There's multiple, so of course not gonna work, but for now let's go with this. And then we do level entity, get component, level component. And level, get block coordinates. Location to block. And so let's extract the location. Location as string is a key, as you can see here. So let's do location as string split by colon. X is going to be an integer parse int location split 0, y, z, it's going to be 1 and 2. So we have location now, and then other thing is going to be block prefab name, location to block, get value, and then we do prefab manager get prefab by name, block prefab name. Once again we have to wrap it, prefab by name, prefab block, not prefab by name, block prefab, block entity, sorry, block entity, entity ref, block data, this is going to be block data, block entity, and block entity, get component, block component, block definition we call it, and here we will say that, so we delete this stuff, this is going to be beforehand, so we will do shape output, output shape to vertices. In here we'll do shape provider get shape by ID block def get shape, right? Because that's what we have stored there. We'll have new map texture region mapper, where we have to have let's write our own texture mapper here. Texture region mapper. What's the interface for this texture region mapper? That's what I thought. We write our own here in a second, and the last parameter is the location. So we have X, Y, Z. Okay, and then texture mapper had that texture region. So for that we will use block def get texture for parts get texture ID. If it's not there, texture name. If it's not there, we will return null. If it is there, we want to ask the texture atlas provider to give us a texture for texture atlas for platforms. Was the name, I think, that we were loading it into? It was this one. No. Was this one? Yes. Platforms, and passing the texture name. It's going to be returned. We don't need this anymore. And the rest is needed. We just need to create a diffuse by texture atlas provider get textures. Platforms. For now, we will assume that's just one texture. So, when you have a lot of different textures used in the same texture atlas, you might end up with multiple images. That's why this allows us to return list. But for now, we'll assume it's always going to be fit in one texture. Therefore, we'll be able to just do it in one go. Other than that, you'll have to go multiple passes through every texture, check that the texture is in the same texture, that is in the same texture, and so on. So it's going to be complicated, but for now we can do this, assume that it's only one, and let's see what's going to happen if we actually execute the program, run the program. I hope you're going to see the two platforms, one with grass, one with stone. No, something has happened. There is no... we haven't loaded the... Yes, so you tried to get an entity with level component, but we didn't load it yet. So in our platformer, after startup, we'll do context get system level loader. And we're going to load level. For now, we are hard-coded here. You can imagine in the real game, you would have a game startup screen where you choose a level or just load the first level and so on. But for now, we'll just load the sample one. So let's run it. Let's see if this works. Okay. As you can see, we see 3-block platforms here made of grass and a 2-block platform made of stone. We can also delete this part because this is not needed anymore. This is done automatically for all the possible blocks in our game. Run again and make sure that everything is working. Yeah, we have it here, and the FPS has not really decreased anything because we just create the mesh once only when we initialize the rain. Okay, let's now duplicate this one, duplicate the level, let's call it sample 2, And in addition to stone, here we'll create at -4, 0, 0 a dirt block. Let's load this one to make sure everything is working as needed. And as you can see, the dirt block has appeared here because now we have the second level. So now we can easily create the levels by just creating a text file. We can easily create the blocks by specifying what shape they are and what kind of texture they use on which sides. So we can create now levels and blocks that are just therefore looks. We can create them in a text files, so everything else is working automatically, and we just wrote 3 classes for it, which is pretty awesome. Okay, I think that's where I want to finish the fourth episode. So thanks for watching, and bye.